Hello students, today we discuss Newton's second law of motion. It states that the rate of change of the linear momentum is directly proportional to the impressed force and takes the direction in which the force acts. That means the momentum produced in a body is proportional to the force that we are applying, and the body will move in that direction in which we are applying the force. Now we come to its derivation. For its derivation, let us consider a body of mass m moving with initial velocity u. Let we apply a uniform force F, and due to this uniform force F, after time t, the velocity of the body will be, that means final velocity of the body will be v. Then momentum corresponding to the initial velocity, that is initial linear momentum of the body, is equals to mass into initial velocity, which is equals to mu. Now momentum corresponding to the final velocity of the body, that means final linear momentum of the body, is equals to mass into final velocity, which is equals to m into v. Therefore the change in linear momentum in t seconds is equals to final linear momentum minus initial linear momentum, that means mv minus mu. Therefore rate of change of linear momentum is equals to m into v minus u by t, which is equation 1. But as we know, acceleration is equals to rate of change of velocity. So here a is equals to v minus u by t, and substituting this value of a in equation 1, we get rate of change of linear momentum is equals to mass into acceleration. Now also, according to the Newton's second law of motion, rate of change of linear momentum is directly proportional to the impressed force. Now combining equation 3 and 4, we get impressed force directly proportional to mass into acceleration. This implies that F is equals to kma, where k is the constant of proportionality. Now if we take the mass of body will be 1 unit and acceleration 1 unit, then force possessed by it is 1 unit. So here k is equals to 1. So for this the value of k is 1. Now substituting the value of k is equals to 1 in equation 5, we get F is equals to mass into acceleration. This is the Newton's second law of motion. Force equals to mass into acceleration. Mathematically, force is the product of mass and acceleration. Here the second law states that greater the mass, as force is directly proportional to the mass and acceleration, so as mass is greater, the mass of the object is greater, then force then its force will be greater. Okay, that means applied force depends upon the mass and acceleration. Thank you everyone.